This video, I'll give you guys a basic walkthrough for the code base that is required to run the Kafka protobuf streams by Bitquery to get the real-time data in low latency, which is for meme trade data for this video. The code base is in the Python, so most of our major code base is in this file named for meme underscore trades.py. So without any further delay, let's jump into it. Now, firstly, we'll see a bunch of import statements. These are the packages that should be installed by you. And these are the files that we have created to organize the code. This constants.py file is the file that has our Kafka username and the password. Now, this line, what it does is it generates a random hexadecimal string. Now let's jump into the next part of the code, which is the configuration. So you can see these are the server endpoints. When we have group ID, the timeout, security protocol. Here we have our username and password, and the auto offset reset as the latest. Now to access the latest data from the Kafka stream, we need to initialize our consumer, which we can do using the consumer builder and passing the value of conf in that. Then we have to define a topic that we want to subscribe. So our topic is BSC dextrates.proto. So basically we want the so basically we want from the protobuf Kafka stream the BSC dextrates. So now we subscribe to the topic and we are mostly using three functions. One is the process message, one is convert byte, and one is print underscore protobuf dot underscore message. So let me briefly explain what each function does. So in order to read the data from the protobuf stream, we use this function which converts the data value returned by protobuf into a human readable form. Now let's understand the print underscore protobuf underscore message function. What it does is it basically parse through the objects passed by the protobuf stream and convert it whole into a human readable format. So this is the code. You could check each and every line by detail, but I'm skipping that part. And the third and most important function is the process underscore message function. So what it does is it tries to get a buffer, which is the message dot value. Then we define the passed message, which is text block message dot p2b dot text block message. So basically at this point we have got our protobuf object message. So basically at this point we have got our protobuf message object. And now what it does, and now in the next line, what we are trying to do is we are trying to parse the message. So basically returning a JSON-like format. Now we are defining a trades variable, which is the passed underscore message dot trades. And now what we are doing is we are iterating for trade in trades, and we are defining the variable dex as trade.dex. Then we are defining the address at dex.smartcontract. Now generally what you guys now generally what you would think is why can't we do chaining like trade.dex.smartcontract? But actually that's not quite possible with the protobuf data format. So we have to go by this approach. Then what we'll do is we'll convert the address to a human readable format, which is a string, using the convert bytes function. And now we are placing a condition that if address is double equal to this particular string, which is the for meme text address. No, actually it is not. This is the for meme text address, but during my debugging, I have found that the address that it returns doesn't have the OX value for anyone. So this is one thing that you could keep in mind. So if it's equal to the forming text address, what we'll do is we'll print a message, new text block message received at given space and given space, or I should say breaking line, and then we'll call the print protobuf message function, pass in the passed message and encoding as the base 58. If that's not the case, then we'll just print that trade in another text. And here is our error handling functions. So now in the main file, what we'll do is we'll try while true, that is for an indefinite amount of time, the message as consumer.poll and timeout equal to 1. If message is none, we'll continue, we'll run this again. Then if message.error, that is if message has an error and the error dot code is Kafka error partition end of file, then we'll continue. That is, if there's nothing left to read and that's causing an error, then we'll just continue to get the next message. Else, if there is any other error, we'll raise a exception. And then finally in this loop, what we'll do is if we have a message, if it has not ended, so we'll process the message. Now we have placed some other exceptions as well, which is for the keyboard. The one is for the keyboard interrupt in case we process Control C to stop in between. And here is a finally statement block, which is consumer.close to close the running consumer instance. Now I'll run this script using this particular command. You could just run it using the play button over here, but I prefer it this way. I'll hit enter and you can see this is the data I'm getting. So these are the trade in error text cases, and in cases where the when an object is returned, these are the cases when a trade is happening on for me. Now, one more question that you would have in your mind would be that why Kafka, why protobuf streams, and not WebSocket or any other solution? So, simple answer to that question would be that if latency is the most important aspect of your use case, then we would recommend the Kafka and Kafka protobuf solution. And there is a document in our documentation that shows a comparison of speed. You can check that out as well. So thanks for watching, like, share, and subscribe, and make sure to join the Telegram channel from the description of the video if there are any doubts. Also, I'll be sharing the link to repository in the description as well.